Hello everyone, I am Chandana. I am currently pursuing my second year engineering in Sri Venkateshwara College. Today I am going to give a presentation on evolution of digital IC technologies and its naming patterns from the subject digital designing and computer organization. Let's come to the topic evolution of digital IC technologies and its naming patterns. Let's come to the introduction to digital IC technologies. Digital integrated circuits are foundational components in modern electronics. They combine multiple functions into a single chip, enhancing performance and reducing size. Understanding their evolution helps in grasping the advancements in technology and naming conventions. They combine multiple functions into a single chip, enhancing performance and reducing size. Let's come to the early developments in digital ICs. The first digital ICs emerged in the 1960s, primarily using bipolar technology. These early chips enabled basic computational functions, paving the way for modern computing. The initial naming conventions were often based on the functionally or logic family, such as TTL, means transistor logic. These early chips enable basic computational functions. Let's come to the shift to CMOS technology. CMOS means complementary metal oxide semiconductor. In 1970s, CMOS technology began to dominate. CMOS offered significant power savings and higher integration densities compared to bipolar counterparts. Naming conventions transitioned to include references to CMOS as seen in the 74HC series, which indicated high-speed CMOS chips. Let's come to the rise of programmable logic devices. The 1980s saw the introduction of programmable logic devices such as FPGAs and CPLDs. These devices allow users to configure logic functions on demand, revolutioning circuit design. Naming patterns for PLDs often included references to the configurably such as Flex and Altera. These devices allowed users to configure logic functions on demand. Let's come to the advancements in technology nodes. In 1990s and 2000s marked a transition to smaller technology nodes, enabling more complex designs. Naming conventions began to incorporate the process technology size like 90 nanometer, 65 nanometer, and so on. As nodes shrank, manufacturers started to emphasize performance matrices and power efficiency in their product names. Let's come to the integration of mixed signal ICs. The integration of analog and digital functions led to the development of mixed signal ICs in the late 1990s. These ICs are crucial for applications such as data conversion and signal processing. Naming convention often reflect their mixed capabilities with a designation like ADC, analog to digital converter, and DAC, digital to analog converter. These ICs are crucial for applications such as data conversion and signal processing. Let's come to the system on chips revolution. The 2000 ushered in the era of system on chips designs integrating entire systems onto a single chip. Uh, System on chip combine process memory and peripherals, optimizing performance and power consumption. Naming conventions evolved to highlight the integration, often using terms like system on chip or specific application names. System on chip combine processor, memory, and peripherals. and the power consumptions. Let's come to the rise of programmable logic devices. In 1980s saw the introduction of programmable logic devices such as FPGAs and CPLDs. These devices allow users to configure logic functions on demand, revolutioning circuit design. Naming patterns for PLDs often included references to their configuring, such as Flex and Altera. Let's come to the early developments in digital ICs. The first digital ICs emerged in the 1960s, primarily using bipolar technology. These early chips enabled basic computational functions, paving the way for modern computing. The initial naming conventions were often based on the functionally or logic family, such as TTL. Let's come to the future trends and naming patterns. As technology advances, trends like 3D stacking and heterogeneous integrations are becoming prominent. Future naming patterns may reflect functionally integration levels and new architectures such as AI or quantum computing. Keeping abreast of the changes is crucial for engineers as they influence design choices and market competitiveness. Thank you.